Hello everyone. In this video, I am going to discuss about solution of non-homogeneous linear differential equations with constant coefficients by method of variation of parameters. Let us discuss the method. Method of variation of parameters. Now this is the method. Now to find solution by this method, let us consider second order differential equation like this. Let us say this is the given differential equation. Here k1, k2 can be either functions or constants. But in this video, I am going to take k1, k2 as constants. Now q is a function of x. Let us say this is the given problem. Now to find solution by this method, first write down the complement, write 1 in operator form as f of d into y equals to q of x, where f of d equals to d square plus k1 into d plus k2, where k1, k2 can be either functions or constants, but in this case we are taking k1, k2 as constants. Now this is the first step. Second step is find complementary function of this problem. Find a complementary function of function of this one. In my earlier video, we discussed how to find complementary function. Let us say complementary function is c1 into y1x plus c2 into y2x. y1, y2 are two independent solutions of f of d into y equals 0, where c1 and c2 are arbitrary constants. Now next step is in this method we consider particular integral equals to sum a into y1 plus b into y2. Here a and b are functions of x. Here in complementary function we are simply replacing c1 and c2 with a and b. Here c1 and c2 are arbitrary constants. We are replacing c1 and c2 with a and b. A and b are functions of x. Now this is the way to write a particular integral in this method of variation of parameters. Now here a is given by minus of y2 into q by w. W is called Ranskin dx, and b is given by integral y1 into q by w. W is called Ranskin dx. Now this is the formula to find, these are the formulas to find A and B. A is given by minus of y2 into q by w, and B is given by like this. What is W? W is called Ranskin, that is given by determinant of y1, y2, y1 dash, y2 prime. Now finding determinant of this one, that gives W. Now this is the way to find A and B, and this gives the particular integral by this method. Then next step is, step 3 is required general solution. General solution of given problem 1 is given by required solution of this is given by y equals to complementary function plus particular integral. Now already we have written complementary function. Let us say this is a complementary function, and particular integral is given by this one. Here C1 and C2 are arbitrary constants. A and B are given by these two formulas. Now this is the required solution of the given problem. This method is known as method of variation of parameters. Now let us discuss a example. Solve y equals to cosecant x by the method of variation of parameters. Now this is the given problem. Now clearly it is a non-homogeneous linear DE with constant coefficients. Now let us find solution of this one by method of variation of parameters. Now to find solution of this one, first write down what is the given problem. Now this is the given problem, d square y by dx square plus, let us say this is 1. Write this in operator form. 1 can be written as d square plus 1 into y equals to cosecant x. Now here we take this as f of d. It is a polynomial in D where f of d is d square plus 1 and q is cosecant x. D is nothing but differential operator. Now next step is we have to find a complementary function of this problem. To find complementary function, we write a auxiliary equation as like this. That is nothing but m square plus 1 equals 0. Solving this quadratic equation, we get m equals to plus or minus I. Now clearly it is of the form alpha plus or minus I beta. In this case alpha is 0, beta is 1. Clearly these two roots are complex and distinct. So complementary function is given by C1. Here e power 0x is 1. So okay, let us write like this. C1 cos beta x plus C2 sin beta x. This is nothing but simply C1 cos x plus C2 sin x, where C1 and C2 are arbitrary constants. This is a complementary function. Now let us take this equals to like this. I am writing this as like this. In this case, y1 is nothing but cos x, y2 is nothing but sin x. Now let us find particular integral by method of variation of parameters. Now by method of variation of parameters, pi is given by, we consider pi equals to yp equals to, in place of c1 and c2 we replace c1 c2 with a and b. In place of c1 we are writing a, in place of c2 we are writing b, and y1 is nothing but cos x, y2 is nothing but sin x. Now where a and b are given by, a is given by, this is the formula to find a by w Ranskin, this is the formula to find b it's very easy to remember. To find a we write minus of integral y2, a is nothing but coefficient of y1, so y2 into q by w into dx, b is a quotient of y2, so we write integral y1 into q by w dx. Now let us find what is a Ranskin. Ranskin is given by w equals to simply we write w, or you can write w of y1 comma y2 integral determinant of y1 y2 y1 prime y2 prime. Here y1 is cos x, y2 is sin x. Now derivative of cos x is minus sin x derivative is cos x. Let us find determinant of this one. If we find determinant of this one, we get cos square x plus sin square x. This is nothing but 1. Clearly it is non-zero. So now let us find a and b. Now this is the way to find Ranskin. Ranskin is clearly non-zero number. Let us find a and b. A is given by minus integral y2 into q by w dx. y2 is nothing but sin x, q is nothing but cosecant x divided by 1 dx. Now cosecant x is nothing but 1 by sin x. So sin x can be cancelled here. You will get simply minus 1 dx. This is nothing but minus x. A is nothing but minus x. Now let us find b. Now b is given by, b equals to integral y1 into q by w dx. Here y1 is nothing but cos x into, this is cosecant x by w is 1 dx. As we discussed, cosecant x is nothing but 1 by sin x, so cos by sin is nothing but cot x. So we get here integral cot x dx. We get like this. Now integration of cot x. What is integration of cot x? This can be written as cos x by sin x. If you know the formula, you can write directly. Otherwise, you can do like this. What is, let us take sin x is equal to some t. Now differentiate this one, you will get cos x dx as dt. So in place of cos x dx, replace with dt, you will get dt by t. Integration of 1 by t is nothing but log t. So this is nothing but log of, here t is nothing but sin x. Now this is integration of cot x. Let us write that. This is integration of cot x. Now this is b. Now after finding a and b, write down in pi. Now pi is given by, now pi equals to, a into a is minus x into y1 is cos x plus b, that is log sin x into y2, that is sin x. Now this gives pi of the given problem. Now finally required general solution is given by, required solution is given by required general solution of 1 is given by, given problem 1 is given by complementary function plus particular integral. Now in this case complementary function is c1 cos x plus c2 sin x. Now pi is given by minus x cos x plus sin x into log of sin x. Now this gives the required solution of the problem. Here c1 and c2 are arbitrary constants. Thank you.